Hi, I'm Sasha Rosenbaum, and today I'm presenting to you on building CI/CD for microservices applications. So first, just a little bit of an introduction about me. I am currently a team lead on a managed OpenShift Black Belt team at Red Hat. And in my career, I have been in development, in operations, in briefly in DevRel, and I spent quite a bit of time in customer success. I still consider myself a developer, but as you can see, I've done a lot of different things along the 15 years that I've been in this industry. I've been involved in DevOps days since 2014, as you can see on the chart as well. And you can find me on Twitter as DivineOps. I post a lot of cat pictures and some technical hot takes. So please feel free to follow me on Twitter. So let's talk about microservices. As I was building this presentation, I was thinking that in addition to how to do things, it's also important to talk about why we're doing things. And especially if we are talking from a developer standpoint, it's important to talk about like why we even use microservices, why we use containers, and dive into kind of overview of the entire architecture. So let's start with this. Once upon a time, there was a monolith, right? And the monolith was pretty, and we actually enjoyed working with a monolith, and everything was relatively okay. And to tell you a little secret that no one likes to talk about anymore is that monolith was actually easier to deal with. Because in monolith, you had full control over all the parts of your application, all of your dependencies and all of the things. And also because distributed systems are hard, and that's just a universal truth, right? But monolith also had challenges, and these challenges were among many. So many different teams needed to collaborate, right? So you had to collaborate across different parts of a company. And if the company was large, that often meant that something like a large airline.com became a behemoth, became a huge beast, and all the different teams had to be involved in building that huge application. Everyone had to be using the same technology. So if one team really liked Java and another team really liked C#, they had to choose between them. They couldn't use both. Or same with different OS types and things like that. Every change required a regression testing of the entire system, which can be quite time-consuming. Deployment, therefore, was slow, right? Because teams were often running into merge hell, and scaling was difficult. So scaling a huge beast of an application is usually not a picnic. So because we had challenges, where there's challenges, there's always solutions. And in this particular case, the solution became microservices. So what's really microservices? So we started with an application, and then we started talking about proper patterns of development. So we modularized different parts of application. And then we started talking about breaking these different modules into different services. And as we went, it became a network of services. And in proper implementation, each microservice also is supposed to own their own data. In practice, this doesn't always happen, but this is the implementation best practice for each microservice to also own the database, right? So I often hear questions about service-oriented architecture versus microservices. So if you're on the left of this diagram, right, and you have a data layer, and you have a business logic layer, and you have a web layer, even if these three layers are separate, you're still not in microservices, right? Separating by vertical concerns is still not microservices. Microservices separate by business logic. So in this case, for instance, authentication would be a separate microservice, right? And it can scale independently of the HTTP listener that serves the web application, right? So if you are breaking by business purpose, you are in a microservices world. So microservices, and this is from microservices.io, right? They're defined as an architecture pattern of collection of services that are loosely coupled, independently deployable, organized by business capabilities, and owned by small teams. So the biggest benefit of microservices, and the reason that all of the industry went with microservices, is actually that microservices enable agility. And that's the biggest benefit, right? Because compared to the huge monolith deployment, you can move much faster with microservices. So the old school is loving the monolith, and the new school is microservices applications, which are typically supported by Kubernetes, or in my case, I work for Red Hat, so I'm going to be mentioning OpenShift a lot, which is a kind of like a version of Kubernetes, if you will. So benefits of microservices stem directly from the architectural description. So they can scale independently. So if you need only one instance or only 3 instances of authentication service, and you need 15 instances of, let's say, photo upload service, you can scale them independently. You don't have to create VM for the entire monolith that does all of these things. You can deploy them independently, which is something that enables agility. You can rely on different tech stacks. So if I want to use Python and you want to use Java, then we can definitely do that. And each service will support the technology that's best applied to it. And then they can rely on conflicting dependencies, which can also be a huge benefit, right? Because if I need Python version 2 and you need Python version 3, if we were in a monolith, we would be conflicting with one another. But now we can have different microservices relying on different versions of the same library. And most importantly, you will be a microservices developer, which will make you a Silicon Valley unicorn in a proper fashion. And this image is from GitHub.com 503. This is a 503 error, but it just happens to look really nice. So why use containers? So I hear a lot of people basically saying that containers are a must for microservices implementation. I like this quote from Jeffrey Richter, who wrote like 18 different books on computing. Basically, microservices are an architectural design pattern, and containers are an implementation detail that often helps, right? So you technically don't have to have containers to implement microservices, but it is often making your life easier. So why do we use containers? Well, so here a metaphor from a shipping industry actually helps. So a shipping industry used to ship every workload in a separate type of box and handle it separately. And then shipping industry actually adopted containers, so these huge shipping containers. And you can see that in the 70s, where the shipping industry adopted containers, there was actually exponential growth of the global trade, right? Because shipping containers was a lot easier. You could standardize on one particular procedure. And so you didn't have to handle every single workload in a different fashion. And that allowed you to build ships that support containers, to build procedures for like offloading, unloading on ships and stuff like that. And it basically enabled explosive growth around the entire industry. And kind of like that, those benefits are also kind of true for computing containers as well. So if we're talking about container technology, it is immutable, it is portable, and it is relying on open source and open standards, right? And so these are huge benefits, but like, what does it actually mean? What problem did we actually solve by containerizing everything? Well, in the reality, we solved the problem of it works on my machine, right? So in the previous life, it used to be that I could be a developer and I implemented something and it worked on my machine perfectly. And then by the time it made it even into test environment, things didn't work anymore. So basically this meme comes from Cam's blog, but it says, it works on my machine, then let's ship your machine. And that's how Docker was born. So essentially we figured out a way to ship a development machine, and that container can be shipped and can be work portably across different environments. So I no longer care if I'm in the cloud, if I'm on premise, if I'm on my laptop, right? I can package the same container and it can run anyway. Now, this is not necessarily completely transparent, but it definitely enables us to sort of eliminate a lot of the challenge of differences in environments. So let's talk about containers, because it's actually relevant to how to implement CI/CD for microservices, in specifically if you're running on a Kubernetes implementation, which you probably are, right? So a container is the smallest compute unit, and it's actually instantiated from a container image. So it's a little bit similar to like a VM image, if you're familiar with those. But basically you create an image of a container, and then you can instantiate a container at runtime, and you can instantiate many containers from the same container image. So container image has different layers. So you start with a base Linux. It's typically Linux. There are Windows containers out there, but there aren't many of them. And then you have the OS update layer with the things that you need. You then have a runtime layer for your language for your application. And then you have the actual application layer. So basically, if you're using the anatomy of a Docker file for a JavaScript application is similar to this. So basically, you pull in an image from a registry. There's typically a registry where images live. And if you are in a company, in a big enterprise, you're probably pulling from an internal registry. If you are just building for yourself, then maybe you're pulling from like Docker Hub or some publicly available registry. And then you have basically defining your environment variables. You can install dependencies. So your dependencies tooling basically depends on your base image and on the runtime that you need. So in this case, we are going to copy over package.json, copy over package log.json, and run npm install to install our dependencies. Then we're going to copy the actual application. We're going to expose the ports which are needed by the application, and then we essentially run the app, right? So in this way, we just package the entire version of our application into a container. And so now I can spin up this container in different environments. And like I said, it's going to be portable. It's going to be working the same way in many different places. So essentially, container images are then stored in image registry. And then I could have different versions of the same container in the registry, right? So as I create new versions of my application, I can create new versions of my container image, and then I can push them into the registry, and then they become available. So I could essentially also pull the different versions. So if I wanted to run, let's say, frontend 2.0 with Mongo 3.6, I could run this combination of services. So de facto, there's Kubernetes is everywhere, and basically it is the standard for orchestration of modern app delivery. It provides lots of extensibility, lots of customization, and a great community of open source contributors, and it just became this big technology that powers everything. And then, yes, of course, the developer take on it is like, I just want to write code, right? Like, let me just write code. I don't really necessarily care about the platform. And that's kind of where we're trying to get to where the Kubernetes platform can actually be abstracted away, and you as a developer don't have to necessarily worry about where your application is running. And of course, it's important to use Kubernetes because you can then put it on your resume and become a Kubernetes developer in a Silicon Valley unicorn. So let's talk briefly about challenges with microservices. So not everything is rosy. We didn't solve all of your problems. We just created different types of problems with microservices. So basically, creating microservices is easy. Getting microservices to play well with each other can be hard. So one of the things that happens is microservices are actually defined, integrate using published APIs. So think about it as a contract. You essentially have contracts between different microservices. And so if someone breaks this contract without updating documentation, without updating your team, they can essentially break every service that's dependent on them. And so instead of merge hell and integration, where all the teams come together and then have to merge it, you essentially just have this situation where someone can ship a change without a dependency on you, but you then can find out that it no longer works with your particular service. The other thing is it's a network. And so when there's this failure in a network, it can create cascading failure across the entire network, which can be a huge problem. So you need to handle that. You need to be able to isolate a failure. And that can be hard, and that can require additional implementation. And so a microservice, it's a common saying that a microservice can only do one thing, right? You're only doing a microservice if it's responsible for a single business logic thing. But then there's this joke of if your microservice only does one thing, it can't have an error because that would be an additional thing. Now, it sounds like a joke, but it's actually true. In many implementation patterns, if your agent is stuck, if your particular container is stuck, it can be really hard to identify if it's still working on something or if it's actually stuck and needs to be killed. So this is something that we need to worry about at container orchestration level as well. So to summarize, the challenges of microservices are essentially that more services mean more network communication, which requires more failure and timeout recovery code. So this is something that you as a developer have to worry about. It decreases overall performance due to network hops and the continuous serialization, deserialization of objects. It's hard to test in isolation without dependent services. So you can't really, it can be really hard to stop everything out and be able to test a service in isolation. It's hard to debug and monitor across different services. And new services must support all the new API contracts simultaneously, which is, again, if you were implementing CI/CD before, you might have been worried about this as well because you want to support multiple versions of the same code. But as you're rolling out new microservices, it becomes even more important to be very, very clear about what your API version is, and so that the services that depend on you can be able to select the API version that they actually are able to work with. So automating deployments, and finally got to the CI/CD part. So basically, you could use the existing pipelines. So hopefully you have CI/CD pipelines of some kind already. And you could use Jenkins or Azure DevOps or something like that for sure to deploy Kubernetes, to deploy microservices onto Kubernetes or OpenShift platforms. But it helps to use something that's, and I will use the buzzword cloud native CI/CD, which is designed for Kubernetes. So essentially, it's a pipeline as a service. So we are putting everything into containers. So pipelines actually run in containers, and it's native to Kubernetes. It's native to Kubernetes authentication and things like that. So one of the potential services, and the one that Red Hat is using is Tecton. So Tecton is an open source project supported by the Continuous Delivery Foundation. And it is basically declarative Kubernetes native CI/CD. The pipelines run on demand in isolated containers. You don't have to maintain a Jenkins server or something like that. And there is a task library that you can pull from. And again, it integrates with Kubernetes and has a bunch of different integrations with existing tools. So essentially, a Tecton pipeline is similar to pipelines that you might have seen before. So essentially, it's comprised of tasks, and every task is comprised of steps. So a step is something that runs a command or a script in a container, and a step also defines what type of container you're using. So essentially that container image you need to pull. Then a task is a list of different steps. So it can be steps running on the same type of container or a different type of container. And essentially you define a sequential, reusable sequence of steps that you need to accomplish a task. The task can be, the pre-implemented essentially tasks can be found at Tecton Hub, which is a public public hub for Tecton tasks. And so for things that happen all the time, such as, AWS CLI task or something like that, you can actually pull it from this library. And then once you have the tasks defined, you can pull it together into a pipeline. And pipeline is essentially a graph of tasks that can run sequentially or concurrently. And they can run on different nodes. They can have conditional logic, and they can have retry. So if a certain step didn't succeed, we can execute it again until it succeeds, right? And it can share data between tasks, which is, again, it's something that needs to happen because often you're handling artifacts between different pipeline stages. So essentially comprising it all together, it gives you a CI implementation for your Kubernetes containers, which also means your microservices application. And then just because we needed more buzzwords in this industry, we created a buzzword for GitOps. So GitOps is essentially an approach to DevOps to CI/CD where everything is implemented, controlled through Git, and everything is essentially declarative, right? And so with in particular with OpenShift, and you can do the same thing with vanilla Kubernetes, you can use Argo CD for the CD part of the application. So essentially, you would have CI pipelines in Tecton, and you will have Argo CD on the CD side, and then the Argo CD is the declarative GitOps definition that defines which environment your code is actually deployed to. And I like this diagram. So basically, essentially, your Tecton pipelines are building your container images and pushing them into image registry. And then you define basically app manifests that say, okay, for this type of image goes into dev environment, this type of container image goes into staging environment, and so on and so forth. So essentially implementing in a declarative fashion desired state configuration through Argo CD for what your application actually look like in each different environment. And of course, now everything is automated and you're a Silicon Valley unicorn, and everybody's really happy and everybody's using microservices successfully. So cloud native application development is about becoming faster. It's not necessarily going to make your life easier on every dimension, but it does enable companies, in particular developer teams, to move faster with deploying their applications into production. And thank you so much for being with me today. I am Sasha Rosenbaum. You can find me on Twitter, on GitHub as DivineOps, and it's a pleasure to meet you.